everyone, Miss Patsy here. Today we're going to be looking into the 4th grade science book called Environments. Investigation 3, we're continuing with the brine shrimp. Part 3, determining viability. Question, does changing the salt environment allow the brine shrimp eggs to hatch? The definition of viability is the ability to live, grow, and develop. So let's get started. In our previous investigation, we were able to hatch brine shrimp eggs in the cups containing 0 salt, 1 teaspoonful, 1.5 teaspoonsful, and 2 teaspoonsful of salt. But we were not able to hatch eggs in any of the other cups. And my question to you is, what do you think that is? What happened in the other cups that made it so that the brine shrimp eggs wouldn't hatch? Now, if you said that it was too high in salinity or its salt concentration, I would say that you were correct. We were testing the range of tolerance of brine shrimp. So we were trying to find out what conditions brine shrimp could hatch in. And our conclusion was that the brine shrimp can only hatch in cups of limited salinity, up to 2 teaspoonsful per 150 mLs of water. So today, what we're going to test is to see if the eggs in the higher cups are still viable or still alive, able to hatch. And we're gonna take 2 cups, the cup with 3 teaspoons full of water and the cup with 4 teaspoons full of water, to see if we could get the eggs in those 2 cups to hatch. But first, I need to figure out how to change the concentration of the salt in these 2 cups to make it so that the eggs will hatch. Well, we know that the eggs will hatch in cups with 0, 1, 1.5, and 2 tablespoons of salt. So we will need to dilute these 2 cups to one of those amounts. And the easiest amount to do would be the 1 teaspoonful of salt per 150 mLs. And in order to change this cup to that concentration, so if we think about this, that cup has 1 teaspoonful of salt and this cup has 3 teaspoons full of salt. If I want to change the concentration in this cup, what would I need to do? If you said that I would need to triple the amount of water in this, you are correct. So if I need to triple the amount of water in this cup, I would need 450 mLs of water. I already have 150 mLs inside, so I need 300 mLs more. So I'm going to get my beaker and add 300 mLs. And then I can add this cup and the salinity in this should have the same salinity as the cup with 1 teaspoonful of salt per 150 mLs of water. Now, how can I change the concentration in this cup to be the same as 1 teaspoonful per 150 cc's? This has 4 teaspoons full of salt. So that means that in order to make it the same as the one with 1 teaspoon of salt, I will need to quadruple the amount of water in here. So I will need 600 cc's of water. And since there's already 150 cc's in here, I just need to add 450 cc's of water. So I will take my beaker That's 450 cc's of water. and the salinity in that is equivalent to the salinity in the cup with 1 teaspoonful of water and 150 cc's. And we'll check back tomorrow to see if the eggs are still viable. Until then, have a great day. Hi everyone, Miss Patsy here at Castile Innovation Lab. It's been 24 hours since we diluted the salt solutions that our brine shrimp eggs were in to see if the eggs were still viable or alive. This is the beaker with the eggs that used to be in the cup with 3 teaspoons full of salt per 150 mLs of water. At first glance, I didn't think any brine shrimp had hatched, but if you are really patient and look really carefully, you will see jerky movements that are different than the eggs just floating around. There's quite a few in there. Now let's check out the other beaker that has eggs that used to be in the cup with 4 teaspoons full of salt per 150 mLs. I don't see any in here. But I also wanted to let you know that I realized yesterday I said cc's for one of the dilutions and mLs for the other. And I wanted to let you know that in case you were confused, mLs and cc's can be used interchangeably. cc stands for cubic centimeters and is usually used for solids, and mLs stands for milliliters and is usually used for liquids. But it doesn't really matter because 1 cc will always equal 1 ml. Well, I still don't see any movement in our cup that used to have 4 teaspoons full of salt per 150 milliliters. So let's check in tomorrow, and until then, have a great day. Hi everyone, Miss Patsy here at Castile Innovation Lab. It's been 48 hours since we diluted the salt solutions that our brine shrimp eggs were in to see if the eggs were still viable, meaning alive. This is the beaker with the eggs that used to be in the cup with 3 teaspoons of salt per 150 milliliters of water. You can see we have quite a lot of brine shrimp in there. You can also see the various stages of the brine shrimp. You see the eggs, which are just the round dots floating around, and then it transforms into what looks kind of like a snowman. And then when the snowman gets legs, that's called nauplii. And then when they start looking like little triangles, that's when they are actually called brine shrimp. As they become brine shrimp, they go through different stages. There's one stage where they look kind of like a bird. And then as they get older, their tails grow longer and they look like a feather duster. Now let's check out the other beaker that has eggs that used to be in the cup with 4 teaspoons full of salt per 150 mLs. You can also see the different stages of the brine shrimp. there are a lot of eggs that are forming into nauplii that look like little snowmen floating around. There is a few hatched brine shrimp swimming around. Actually, those might be nauplii. We didn't see any yesterday, so they must have hatched either later yesterday or earlier today. But it looks like there are a lot of eggs that are about to hatch. Now, why do you suppose it took longer for the eggs that used to be in the cup with 4 teaspoons full longer to hatch than it did the cup with 3 teaspoons full of salt? I actually don't know. I just know that yesterday we had brine shrimp in the 3 teaspoonful cup, but we didn't have any brine shrimp in this cup, the 4 teaspoonful cup. But yet today we do have some that hatched today, which is good. Now, these observations prove that even after soaking in cups of very high salinity, the eggs remained viable but dormant until the optimal conditions occurred. So if brine shrimp were to lay eggs in a salt lake, but the concentration of salt was too high, the eggs would just lay dormant until either rain would fall or streams of water would fill the lake, and then the eggs would hatch when the environment was optimal. Well, I hope you enjoyed our brine shrimp viability experiment. I will see you next time.